So with number 7, we are still solving our system by elimination, and if the system is inconsistent or has dependent solutions or equations, they'd like us to say so. And we're given the system of 8x plus 4y equals 4 and 4x minus 2y equals 12. And you'll recall if you watched the previous video, the first thing we want to look for, and let me go ahead and rewrite, that's an x. The first thing we want to look for is to see if one of our variables, either x or y, eliminates right off the bat. And if that is the case, go ahead and eliminate that variable. In this instance, we don't have a situation where the x or y eliminates right off the bat. So what we're going to do is manipulate one or both of these equations so that we can get either the x or the y to cancel. And I think we'll go ahead and eliminate the x variable from our system first. And since we have a positive 8x here in our first equation, why don't we manipulate the second equation so that we can get a negative 8x here, and so that way these x's will eliminate. Well, right now we're at a positive 4x, so what do we need to multiply a positive 4x by in order to get it to a negative 8x? And if you said negative 2, then you're on the right track. So let's go ahead and multiply this whole second equation by a negative 2. And when we do that, we're going to have negative 2 times 4x gives us negative 8x, and negative 2 times negative 2y is plus 4y. Equals, and then negative 2 times positive 12 is going to give us that negative 24. All right, so now we're dealing with, and let me go ahead and rewrite this first equation right underneath, just so everything lines up nicely. All right, so now we have a situation set up where the x's are going to eliminate nicely, because negative 8x plus 8x, well, those go away. Positive 4y plus 4y gives us 8y. And then negative 24 plus 4 gives us a negative 20. And if we're going to solve for y, we'll divide by 8, divide by 8. And so y equals negative 20 over 8, but that's going to reduce to negative 5 over 2. All right, so now that we've solved for y, let's go ahead and take this value and plug it back into one of our original equations. And of course you could plug in to the equation that we manipulated, that we multiplied by negative 2, but I usually go back to one of the originals. So why don't we take this value, and I'm going to plug it back into the first equation. So we had 8x plus 4y equals 4. And again, we're going to take this value of y and replace the y and plug in that negative 5 over 2. So we have 8x plus 4, plugging in that negative 5 over 2 equals 4. And so now we have 8x, and now we're multiplying fractions here, right? So we're multiplying really 4 over 1 times negative 5 over 2. And again, when we multiply fractions, we don't have to worry about common denominators or anything like that. We just go numerator to numerator, denominator to denominator. So 4 times negative 5 gives us negative 20 over 1 times 2 is 2, and negative 20 over 2 reduces to negative 10 or minus 10 equals 4. And solving for x, we'll go ahead and add 10 to both sides, leaving us with 8x equals 14. And finally, we'll divide by 8 on both sides, and that's going to leave us with 7 over 4. All right, so now that we've solved for y, we've solved for x, let's go ahead and put both of these values into an ordered pair. And there you have it. There is the solution for this system, and we solved by elimination. And again, you could take this solution, plug it back into your original equations, and check to make sure you get a true statement for both equations. If you do, then you know that you have the correct answer. If you only get a true statement for one and not the other, then you need to go back and check your work. If you get a false statement for both of them, then definitely go back and check your work. All right, so you're looking for a true statement for both of your original equations when you plug in checking your work. All right, let's go ahead and take a look at number 8 in the next video.